Today's lesson is on the nomenclature of molecules, and this will be the last lesson for this unit. It's the easiest system of all the naming that we've been doing. Ionic compounds, I would argue, is the most complex, followed by the acids, and then molecules tend to be the easiest. Just be careful, because with molecules, what students tend to do is they want to do everything with the molecular system because it's so easy. So first of all, before we get into the naming, just remember that there are two broad classes of compounds. We have ionic compounds and molecular compounds. Okay, remember that this is going to have that metal, metal and a non-metal in here. Okay, so that's how we're going to tell the difference between our ionic and molecular compounds. So for the molecular ones, these are molecules here, and these are, oops, forgot the E, and these are your ionic compounds up here. Okay, all right, so for the molecules, you're going to have two non-metals in the formula. And these will always be binary. You always have two atoms at the most in a molecular substance. Ionic, you can have a polyatomic ion in there. There's ions in here. There's no ions here. Okay. Here they share, our electrons are transferred. Electrons are transferred, and that's what causes the charge to form, because an electron moves from the metal to the nonmetal. And for the electrons here, electrons are shared. Okay, and that's going to be the reason why we have to have the different naming systems, because there's no ions here. Here we balance charges, and we do not balance charges in an ionic or in a molecular compound because there's no charges. So we do no balancing. And that's why these tend to be the easier ones. Okay, since there's no balancing. Here we reduce them down. Reduce to lowest terms because of the fact that we have the charges reduced to lowest terms, just like you do with fractions. And over here we do not reduce. Okay, so we keep them as they are. So that's another important feature of the molecules. Okay, because we have these ions that are separated from each other, they're going to attract each other. Molecules act as a group and they stay together. So over here, this molecule of water stays as a little group. It's going to share the electrons to make little globs or little structures called water molecules. We don't have that here. The repeating pattern goes throughout the entire crystal structure, so there's no distinct ending like we have here. Okay, and there's going to be two different types of forces that we'll get into later. And the last thing is, because this one here we don't reduce, we use prefixes. Okay, we use prefixes to name molecules. And here we use no prefixes, unless it's inside the name of the polyatomic ion. Okay, so no prefixes. So that's your difference between ionic and molecular species, once again, just to make sure you're aware. Ionic compounds conduct electric currents, these don't, and go back and review some of the other properties. So, real simple, the system is pretty basic. All I'm going to do is I'm going to just rewrite this based on translating those names. So, if I have a 2 here, first of all, I have to recognize that this is a molecule. 2 nonmetals. 2 nonmetals tells me this is a molecule, so therefore I use my rules. And all I do really is I just translate the numbers. Since I have a 2 here, I'm going to call that di. So you should know your Latin prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, nano, and deca. Okay, if they're on the reference sheet if you need them. Okay, so you should know those 10. Typically we don't go up to 9 and 10, but you should know it. So di-nitrogen, okay, and we would say pent, space, don't have to be capital. Now that would be penta is the prefix, but we drop the A and call it pentoxide. Typically if there's 2 vowels, drop the A. If you call this pentoxide, I'm just going to warn you to drop the A. Not a big deal. You're never going to lose points on that. Okay, again, it's one of those things that you get better with as practice. So for next one, I do diphosphorus, and then I would do tetra. Okay, and then again, since I have tetraoxide, I would do tetroxide. And again, if you had tetraoxide, yeah, that might be okay. Okay, again, it's debatable. All right, one other rule to watch for is that we never use mono on the first one. So no mono prefix on the first element. Notice that these are always going to be 2, right? You're always going to have 2 elements here. Okay, so no mono on that first prefix. Think about it. We don't call this mono carbon dioxide, do we? We call it carbon dioxide. So, no mono in the beginning. Carbon tetrafluoride. And I do just like I did for IDE endings, just like I did for ionic compounds. Okay? And then quickly, just to translate, I just take that tri and I make it a 3. So this is N3 pentoxide, so it's going to be oxygen with a 5. Down here, sulfur dioxide. So this is the easiest of all the systems. So, like I said, don't be misled into thinking you can use this for everything, because you can only use this for molecular. How do you know they're molecular? Because there's 2 nonmetals. Okay, one other thing I wanted to mention is those 7 special diatomic molecules. These are technically molecules. So hydrogen is going to exist as 2 atoms of hydrogen, so this would be H2. So in the gas phase, they always bond together and create a little molecule called hydrogen. Over here is O2. And again, 2 oxygens come together to create little molecules of O2 gas. So when we have hydrogen, oxygen, nitrogen, chlorine, all these by themselves, they are always going to form little groups or little molecules. So never write H by itself. You always have to write H2. You could write it as HCl. That's fine because that's a compound. That's different. This is when I'm writing hydrogen by itself. I have to keep it as a diatomic molecule. Keep in mind that these are actually little molecules. Why? Because it's 2 or more atoms that are sharing electrons. They're sharing electrons there. Okay. So that's pretty much it. So that is the end of this unit. A little recap of naming, formula writing here I've got on this last slide. I'm going to pause it and write this stuff down. But this is pretty much what I had at the beginning there. So some things to remember, stock numbers and charges on the ions, when to use prefixes, the 8 and the ic and all that stuff. Okay, so if you need this, it's here. Don't forget to pause it, write down what you need. But I'll see you guys later. Thanks a lot.